Okay, let me show you guys how to solve this application problem that deals with the bearing. Right here it says, two ranger stations are located on an east-west line, and they are 100 miles away from each other. And right here it also says that we have a fire that's located on a bearing of north 42 degrees east from station A. And we know station A is on the west side. And we also know that a bearing of north 15 degrees east from station B, and B is on the east side. And the question is, we would like to know how far is the fire from each station. And suppose you are on one of the region station. If you are closer, then it will be your job to go and then pull out the fire, right? Anyway, to solve this kind of questions, we must draw a picture. So here we go. Let's draw the A and B stations right here, right? So let me just say A is right here, which is on the west side. And we know we have to go 100 miles away like this. This is going to be the B. So this is 100. And let's not put on the units. Let me just draw 100 like that. And now, right here it says, the fire is located on a bearing of north 42 degrees east from station A. So this is going to tell us, let's go to A first. And I have to look up to the north direction. So I'm going to draw a straight line up like this. This is the north direction. And I will have to turn 42 degrees east. That means from here, I will have to turn to the right because that's the east direction, right? So we have to turn 42 degrees. So it's going to look like this, something like that. And this right here is 42 degrees. And this is just the direction. I don't know how long this is going to be. Okay, I don't know how long this is going to be. So let me just kind of draw it. Let me just extend this line like this maybe. All right. I don't know when I have to stop though. And on the other hand, we have a bearing of north 15 degrees east from station B. So similarly on B right here, we first look up. This is the north direction. And we have to turn 15 degrees toward the east side, which is toward the right again. So I just have to turn a little bit right here, right? This much is the 15 degrees. Hopefully you guys can see it. And this is the direction I have to go, isn't it? And once again, I don't know how far this is going to extend. I will just have to draw it. Right? I'm just going to extend it. And of course, we're talking about the same fire, so they will have to meet somewhere. And let me just say they are going to meet right here. And let me just draw my picture better so it looks like a triangle, all right? So this is the picture that we should have, something like this. Hopefully you guys don't mind. Anyway, here is the fire. Let me just indicate that with fire in red, all right? Like that. Here's A, here's B. I will just call C to be the location of the fire. Anyway, this is a triangle that we have, and we have this side. Ideally speaking, we should find out all the angles inside of the triangle so that maybe we can use law of sine or law of cosine because this is not right triangle, right? Okay, let's figure out what's angle A, and let me just show you guys the work right here. Measure of angle A. You see, earlier when you look up, that's the north direction, and this right here is horizontal. So altogether it's 90 degrees. And this much right here in red is 42 degrees already. So to find out the measure of angle A, we just have to do 90 degrees minus 42 degrees, which is going to give us 48 degrees, all right? And I'll label this right here for you guys. Here is the 48 degrees. And now let's solve for measure angle B. So it's this right here that we're talking about. Okay, you see, this is horizontal in black, and this is vertical in red. So this right here is 90 degrees, isn't it? Yeah, this right here is 90 degrees. And earlier, we turned 15 degrees more. So altogether, from here to here, this is a total of 105 because we have to do 90 degrees plus 15 degrees, and that will give us 105 degrees. And that will be measure angle B. So let me just indicate that for you guys right here. And lastly, once we have this angle and that angle inside of the triangle, for measure angle C, which is right here, measure of angle C, we know altogether they have to add up to be 180 degrees, right? So we just have to do 180 degrees minus 48 degrees minus 105 degrees. And altogether, just subtract, you end up with 27 degrees. And that's going to be measure of angle C right here. So this is how we fill in all the information. And now, the question is asking us, how far is the fire from each station, right? So I need to figure out this side, and likewise from this side, right? And this is how we do the labeling in this kind of triangle. This is angle B, right? This is angle B. When you go away, when you go across, I will label this side as little b. And likewise, this is angle A. When I go away, we'll go across from this angle. This side is going to be little a. And since this is capital C, when you go across, this is going to be labeled as little c, right? And now you know we have an angle and a side, right? C and C, they match. So it's good that we can use law of sine. So let me just set this up for you guys. We'll use law of sine. So first, let's put down sine of C over C. This is capital C, this is little c. And we know this is going to be the same as, let's solve for little a first, if you guys don't mind. Well, C and C match. You know the other one, the setup will be sine of A and little a, like that, right? Okay, so we're just going to be plugging numbers. C is 27 degrees, so on the left-hand side, we have sine of 27 degrees over little c, which is 100. So let me just put this down right here. And that will be equal to sine of A. We know what A is, which is 48 degrees. So let's put that down right here. Oops, 48 degrees. Over little a, which that's the variable that we're trying to solve. So let's put down A right here. And now, if you would like, you can cross multiply or solve it whichever way that you prefer. But I will cross multiply for you guys, like this, all right? This times that, we will have A times sine of 27 degrees, and then this times that, which is 100 times sine of 48 degrees, right? And then I will have to divide both sides by this, sine of 27 degrees, and right here as well, sine of 27 degrees. So that this and that will cancel. At the end, you can just get A is about equal to, you punch all this onto your calculator, right? And be sure your calculator is in the degree mode. And after you work this out, you will get the A value. It's about 163.69. And that's this side right here, right? And then you can come here and then just label that if you like. Okay, and now let's solve for B. Similarly, I will just use sine C over C. This is going to give us sine B over little b, right? So I'll just put this down here for you guys. C and C, we know that right here already. So let's put this down, sine of 27 degrees over 100. And this is equal to sine B, which is 105 degrees. So let's put that down right here. Over little b, we don't know. So let's put that down. And once again, we can cross multiply, and this is going to give us b times that, b times sine of 27 degrees, and that will be 100 times this, right? 100 times sine of 105 degree. And now, of course, do the same thing, divide both sides by sine of 27 degrees, divide this by sine of 27 degrees as well. Cancel this out, and we see b is about equal to, work this out on your calculator, and you will get this is approximately 212.76. Okay? So we are pretty much done. However, this is a situation problem. We have to answer it with a complete sentence, all right? Because if you just say A and B, doesn't really make that much sense. Because this A does not tell you the distance from the fire to station A. This A tells you the distance from the fire to station B, right? This is how we like to label it. So here is how we are going to answer the question. I will just say the fire is 163.69 miles, approximately speaking, right? The fire is 163.69 miles from station what? station B, okay? And on the other hand, when you have the little b value, this is actually the distance from the fire to the station A, right? So I will just tell you guys right here. On the other hand, the fire is 212.67 miles from station A, right? And this is how you should answer the question whenever you have a situation. And that's it.